Welcome back to the next section, and this section of the Introduction to RS5000 Lab Manual we titled Creating a Slick Looking Database, or Understanding the PLC5 Slick 500 Micrologix Database. Truly, the greatest obstacle to adapting to the Logix engine and its database is the absence of pre-declared variables. In this project, we will create something that is as close to a PLC5 Slick 500 Micrologix looking program and database as you can get with the Logix engine. In other words, we'll try to make the Logix engine look like the old platform so you can see where everything is at in the new platform based on you knowing where it was at in the old platform. And once again, I want to reiterate, if you did not do the training on 500 with the first manual that we produced, you probably aren't going to correlate with this project. And we place this project here because you need the module defined data types exposed to complete this exercise. Make sure that you have a digital input module and a digital output module in your project. So to do this particular lab exercise, you're going to need to open a project that you've created that has at least an input and output actual module in the I/O tree. This is a graphic that I created that is that's on the first page of this lab section, creating a slick looking database. And here we're comparing the project view or the project explorer between the Slick 500 and the Logix. I realize at the top of the second one it says controller SLC500. That's what we named our controller, the L35E. It's not a Slick 500, but we named it that because that's what we named our project, because that's the point we were going to make with the tags that we created and how we exercise the logic. But if you look down through these two, the one on the left is actually from Logix 500, and that happens to be a Micrologix. Now you can't tell that by looking because there is no I/O tree. Now there's an I/O configuration, and you could open that and then you would see what the processor is, and you would also see what I/O modules have been assigned. So starting at the top, we'll skip help, and the second category is controller. Controller properties, processor status, I/O configuration, channel configuration. Those are all subsets under controller. So if you follow the orange path over to the Logix engine side, you will see that it says 1769 L35E. If you're familiar with the format on the left, Slick 500, its counterpart on the right is as shown. So controller properties would be found by right-clicking on 1769 L35E and selecting properties. More importantly, there's a button in the online toolbar in Logix 5000 that looks like a little processor. You just click on that. You don't right-click. Just click on it, and it opens up a dozen or so tabs that you can select for all the individual properties for the processor in 5000. With 500, there really wasn't much. So if you double-clicked on controller properties in 500 on the left, it would open up and give you some information. Some of it you could change, like the name of the processor, and you could actually change the processor. Okay, so the next category on the left is I/O configuration, channel configuration. Well, follow the dark blue path down to the bottom. That's part of the I/O tree. So really, notice that everything under controller on the left that's the SLC500 side. Everything under controller can be found under the I/O configuration. And remember, the I/O configuration on the right in the Logix engine category is a virtual electrical structure. So everything under I/O configuration in the Logix engine Project Explorer, that is all a virtual hardware image. It shows the processor, shows the Ethernet NIC, Network Interface Controller, little green rectangle sitting at an angle there that looks like a daughter card for a tower computer. And then off of that it shows a cable connection to Ethernet, or we'll call it a port extender. That's not the proper name, but when I think of a connector on the back of a computer, and then there's conductors that run from the connector to a circuit card, that connector is just an extension of the port electronics on that circuit board. And then below that you see compact bus local. Now there's no I/O modules shown off of the compact bus local, but if they'd been added, they would show up here. So all of the hardware is going to be under I/O configuration for the Logix engine. The hardware for, we'll call it RS500, I really should have made that graphic down there say RS500 instead of SLC500. Okay, next down is program files. Well, in the SLC500 era, or we'll call it the RS500 era, you had one program file. That was all you were allowed. And within that program file, you had file 0 and file 1, or routine 0 and routine 1, that were unaccessible to you. But they're shown there probably as graphic placeholders, because if it just said ladder 2, LAD2, you would always be asking, well, where's 0 and 1? Well, 0 and 1 are system files, and you can't touch those. This would be a good place for a little music. Can't touch this. Anyway, ladder 2. Ladder 2 is the main routine of the only program, and ladder 2 is the only routine that runs automatically when you put the controller in the run mode. If you add more routines by right-clicking on program files and creating more routines in the RS500 realm, you have to have a JSR instruction in ladder 2 jumping to those other routines. Now that still holds true for 5000 in the Logix engine. So if you jump across the green to the other side, main program, main routine. There the main routine is indicated by a white sheet of paper with a 1 on it. Now the difference in RS500, you could only use ladder logic diagrams, relay logic diagrams, whatever you like to refer to them as. Whereas in the Logix engine, you can use any one of 4 different languages. Each routine can only have one language in it, but you can mix routines within a program, and each routine is using any one of the 4 languages. So this main routine has a symbol of a ladder behind the little sheet of white paper to show that the main routine is ladder logic. Now notice that the Logix engine side has something additional called program tags. The program tags, if you go back over to the left, are what in RS500 would have been B3, T4, C5, R6, N7, and F8. Now, if you don't know what those are, then you didn't do the earlier learning pipe with RS500 and the complete PLC Learn series. So we're not going to explain what those all are right now. And you will find throughout this exercise that we're not going to go into a lot of detail on what these data types are, or these members of the data table of RS500. We're only drawing a correlation between them and the Logix engine. The only thing left is the I/O. Well, that's split out separate in the Logix engine. So notice that program tags between 500 and we'll call it the Logix engine, the program tags are in one section. Now in the RS500, under data files, you have the I/O data files 0 and 1, output and input. They're all in one spot. So all of the data files are in one spot in RS500, but in the Logix engine they are split out. The I/O can only be controller tags. You'll never find I/O tags in program tags. That's two completely separate databases. Remember, controller tags are memory locations available to be exercised by all of the programs in all of the tasks, all the routines in all the programs. Let's go a little deeper. In all of the add-on instructions, in all of the routines, in all of the programs, in all of the tasks. Whereas the program tags are only accessible for exercise by the logic that is within the routines of that one single program. But remember, in the Logix engine, you can have as many as 100 programs in a task, and you can have up to 32 individual tasks. So basically, if you maxed out the Logix engine, you would have 3,201 tag databases. You would have 3,200 program tag databases, because you could have 3,200 programs. Plus, you have one controller tags. Think of the controller tags as access in and out of the back of the controller to the back plane of the system. So in other words, anything that comes in or out from the back plane into the controller, out of the controller onto the back plane, into the controller from the back plane, those tags have to be controller tags. They are the access to the outside world. In I/O, input outputs, they are someplace else, whether in the same chassis or they're available on some remote chassis through two bridge cards into the back plane. Okay, I think we've sufficiently pounded on this graphic. It would have been probably nice if I would have animated it and popped in these colored boxes with the lines one at a time. But I want to take this right out of the manual as you saw it. When you create a RS500 project, you begin with a file O0 and I1 for I/O, but they are empty until you add I/O modules and their data structures, which are unique to each module. And these modules populate and expand those two files. So if you were to open up O0 and I1 in a brand new RS500 project, it would say no data available because there's no modules added yet. Also, when you create a project in RS500, you begin with 6 single element arrays. Some with single word elements, and others like counter, timer, and control data types that are 3 word elements. Nonetheless, you begin with single element arrays that are expandable to 256 elements in each array. The numerical location for these elements is 0 through 255. Taking T4, timer, T4 is a timer data type, you could have T4 0 through T4 255. So each of those data files, B3, T4, C5, R6, N7, F8, begin in your organizer there with a fresh project as single element arrays. 1 word, B3. 3 words, T4, because timer data types are a 3-word element, and so on and so on. So if you want more than 1 word of binary, 1 timer data type, 1 counter data type, remember you need an instance of a timer data type for every single timer. you can expand those out to a total of 256 elements. So these are arrays. These are pre-declared variable arrays. B3, T4, C5, R6, N7, and F8. And I do want to add one more thing. S2 status in the RS500 realm, there is no counterpart in the Logix Engine Project Explorer, but there is a counterpart in the Logix Engine, and those are called system variables. To access those in the Logix Engine, you have to use two very special instructions. If you want to observe a system variable, you have to use a GSV, get system variable instruction. And then within that instruction, an instance of that instruction, you basically declare what elements, what part of that data structure in system variables that you want to look at. If you want to change a value in the system variables, you have to use an SSV, set system variable. So you've got a get system variable and a set system variable. Okay, let's actually create some of these single element arrays in the Logix Engine so you can make your transition from 500 to 5000 complete. In the lab book, we had a sheet called single element arrays, and it said, here are the RS500 views of those 6 single element arrays. And these single element arrays were in the graphic that we just looked at in the RS500 side. B3 binary, T4 timer, C5 counter, R6 control, N7 integer, and F8 floating point. So here are those 6 single element arrays, and it's in your lab manual, and it shows B3, T4, C5, R6, N7, F8. And then we expanded B3 out to 10 elements. And we reminded you that you could expand it out as far as 256 elements. We're not going to repeat the graphic in the video here. The next section was SLC500 looks like data files, single element arrays in the Logix Engine. So we go to program tags right here, because remember that those single element arrays were in the program tags for the SLC500, PLC5, Micrologix platform. So we double click on program tags, and of course we have nothing there. So we're going to go to edit tags so we can add a tag. See, nothing to monitor, but when you go to edit tags, you always get a blank row. Even if you had 1,000 tags in here, if you went to the bottom, you would have a blank row where you could just directly type in a new tag. You can also create tags in the ladder view or in any of the languages. You just type it in, right click, and if the software doesn't recognize it as anything but text, it's going to assume that you want to make a tag out of it, and it's going to come up with the new, and then in quotes will be whatever it was you selected. So you can create tags right in your Logic, or you can create them right here in your tag database. So these are program tags. So let's type in a name B3. Make it an uppercase B3. And then select the data type. Now if you select here, then a little box will pop up here. If you put the arrow in the right place, your cursor, and click on it, it selects the field and selects the ellipse. So we'll do that again. Okay. Well, you know what? I made a big mistake. This is a good thing for you to see. You see how I clicked outside of that row that I was working in, and the data type instantly went gray. B3 is now a double integer whether I like it or not. Now, if I was using that in a program in Logic, I cannot delete that online. However, I haven't used it yet, so I go over to the beginning, I select that row, and then I hit delete. So I can start over. You cannot edit a tag data type once you've created it online, but you can delete it and then redo it. So we'll do that again. B3, that was a good thing for you to see. See, there's nothing in there. So if I click here, then the ellipse pops up. But I could have clicked there before the ellipse was there and killed two birds with one stone. Just a little programming shortcut. Now we want integer, so we type in I, N, and it comes up integer, and we'll click, we're going to put 1 down here. Okay, that's important you do that. If you don't put in 1 for the dimension, the first dimension, you won't get the results you need. So put in a 1 down there for dimension and click on OK. Now watch what happens. I'm going to click here outside of, or over here or anywhere. When I do, see that immediately that tag is created as an array, an integer array with one element, and it's grayed out. I can't alter it. See, I can't go in and do anything there. I would have to go offline to edit it or delete it and start over. So let's expand this to see what we got. B30, 0 through 15. Now, if you look at those tag names, B3 in braces, or whatever you call the brackets, 0.0. So it's B3 file, word 0, bit 0, just like it is in RS500, B3 0.0. Only for delimiters in RS500, you have B3 colon 0.0. Here, our delimiters are those brackets that bracket 0. And that's what separates the 3 from the 0. Otherwise, you'd have B30. That would be a whole different tag. Okay, now let's do another one. Let's collapse this. We'll do another one and we'll call it T4. And we'll do the same thing. Be very careful. Now I'm doing this all online. If you do this offline, which is probably better when you first start, that way if you make a mistake it's easy to fix. So I'm going to click there, kill two birds with one stone, type in T, I, and the only thing left for it to be is a timer. And we want an array of one element. Now, if we didn't put in a 1 here, we left it 0, you would get a tag called timer, and it would be a timer data type. But it wouldn't be a single element array. That's the difference. Okay. Click here. Expand it. There you are, T40. Preset accumulate enable timer timing done bit. So T40 dot preset accumulate enable timer timing done bit, just like in RS500 land. I think I had you do the rest of these. After timer comes counter. So C5, CO, U, dimension of 1, okay. And after C5 came R6. Now R6, that's a controller data type, but we can't use C for controller because we already used it for counters. So R6, CON, T, hit OK. Oh, by the way, we didn't expand C5, C50, preset accumulate, count up, count down, done, over, and under. Control, length, position, enable. Most of these bits you've probably never seen before because you probably don't use much in the way of this data type. But this is exactly the way it looks in. Oops, we made a mistake there, didn't we? You see what it is? What did I forget to do? I was so busy thinking about the data type, I forgot to make it a single element array. So you see the difference here. C50, we'll expand that, it goes right to the tag. So that's easy. We'll just click on that, delete it, You do it again, only takes a second. R6. CONT. Dimension 1. Okay, you'll see in a minute why we have to do this. Okay, so now we got integers and 7. And you're probably noticing this is identical to B3. Well, that's because B3 and N7 in RS500 land are pretty much the same structure. It's just that with the N, it infers you're using them as integers. With B, it's inferring that you're using them as bits. The only thing left is F8. F8. Click over here. Now, it's not called floating point, it's called real. Okay, and there's all of your single element. See, there's F8 0 and 7 0, or 6 0, and so forth. So now we have single element arrays. And they look exactly, almost exactly like they would in RS500 land. You wouldn't access them this way, but this is what they look like. T40, preset accumulate, timer timing, and a done bit. Or by the bit, B300, B301, etc. I think you get the point. Now, if this isn't familiar to you, then you're not familiar with RS500. And if you are highly familiar with some other platform of controllers, that's great. And I'm assuming you're making the correlation between pre-declared variables and the Logix engine, which allows you to declare your own variables. Now, if you convert a RS500, RS5, PLC5, SLC500, Micrologix program over to a Logix engine, you're going to end up with these tag data types. In other words, you're going to get B3, T4, C5, R6, N7, F8, etc. One thing I didn't mention was, where's number 9? Well, you got 9 through 255. So you can create, basically, you can have data file 3 through 255. The first 6 are pre-declared for you, and then you can create 9 through 255, and they can be any of these data types. And each of these data files can be expanded out to 256 elements. Now, in the Logix engine, you are only limited by the size of your memory to how far out you can expand these data types. So if I go to this tag and edit it, and say I can't do that online, I can go back in and change that to any number that I want up to whatever memory space I've got to play with. So if I wanted to make that 1,000, I would have 1,000 floating points in F8. So when I expanded this, it would be F8 0, and it would go all the way down to F8 999, 1,000 elements in F8. We're not going to do that. Now, if we want to expand these arrays, we can do that. So I'm going to have to go offline to do that. So whenever you go offline, always save, unless you don't want to take what you have online and overwrite what's in your computer. In other words, the project exists in your computer offline and in the controller online. So I always save, because I'm seldom in a position where if I upload and save, then I'm going to wipe out something offline that's more important to me. Okay, so I saved, remote run, go offline. Okay, see, everybody's still there. Now we'll expand. In your manual, we had you expand the timer file. So we're going to right click on this one, edit properties. Now you see this isn't grayed out. You have access to this. So I can go in, and in the manual I had you make that 10. Unfortunately, I didn't make my window big enough to accommodate this, so I'm going to have to drop down and click on OK. You can't see it because it's out of your view. I'll have to fix this before I do the next section. Have to make that a little bit bigger. I try to make this exactly 720p, so 720 pixels vertically by whatever it is horizontally. So it would show up as HD 720p on your computer screen, TV screen, whatever. Okay, now let's expand this out. Now look, we've got T40 through T49. If we expand any one of these, we have T44, preset, accumulate, enable, timer, timing, and done bit. So you get the idea here. If you want to create a structure of data files in the Logix engine that looks just like the SLC5 Micrologix, you can do that. And many people, I am almost ashamed to admit that I did do that many years ago. And so I'm writing my program, and I'm using the B3s, T4s, and I'm thinking, now back in RS500, you would have put in descriptions. There was something called symbols, which were unique to each memory location. But then there were also descriptions, which were not unique to any particular memory location, but they were attached to any and all memory locations that you assign them to. So I thought, well, you know, I have the ability to type in this great big long tag name. So why am I using B3:0.0 or B3:0.0 and then adding a description to that when I could just skip the whole thing and put in a tag that's a good description? So anyway, in the lab, all we were doing was expanding the arrays. But real quick, just for grins, I'm going to type in delay, and I'm going to alias it to T4 to T44. Okay, now look, I've got delay, preset, accumulate, enable, timer, timing, done bit. So it ditched, you know, I created this new tag that's an alias for T44 right there, see? Only when I look at it, this is what I get. So why even fool around with this when you could do this? Now, I'm going to do that one more time, just for grins. I'm going to have to give it a slightly different name. We'll just put an X after it, okay, because you can't use the same tag name twice. Now, instead of an alias, I'm going to go over here, type in TIM, okay. Now look, pretend that X isn't there. What's the difference between this and this? Well, if you're going to create a name for your timer, alias it to this, we'll call them pre-declared variables because you pre-declared them before you had any logic, just like in RS500. Why do all that when you can just do this? So I'm going to delete this puppy because it's not doing anything. Then I'm going to edit this one and get rid of the X. Backspace. And again, I'm going to have to pull down my box to hit OK. And bring it back up in the little brackets. I think you're getting the drift here. That these pre-declared variables that you have with RS500 aren't as great as what you thought they were. Now, if you're younger than I am, and I won't tell you how old I am, but I began with a PLC, and then there was the PLC2, the PLC3, the PLC4, the PLC5, which you've probably seen. It looks like a big boat anchor. It looks real dark and dusty. And then, of course, SLC500 came out. Everybody loved that. It was smaller, easier to work with. And then, of course, there came Micrologix. And then in the era when different Micrologix were coming out, they started coming out with Contrologix, then CompactLogix. Now there's also SoftLogix, DriveLogix, and FlexLogix. But we're not addressing those today. CompactLogix, Contrologix are the main players. SoftLogix is also a player, but what I like to say about SoftLogix is it's the Logix engine running on a personal computer, on a regular computer that probably has a hard drive, and it looks like a regular computer to most folks. The problem is you can't separate SoftLogix from the personal computer, or from the PC, or from, if you want to call it, the tower. So whatever the frailties are of a personal computer, of a tower, they are inherited by SoftLogix when you use SoftLogix. So SoftLogix within itself as an application is a great application. And it will actually run faster on the best multi-core tower than it might in a Contrologix processor. The problem is the frailty of a platform with the kind of operating system that allows you to connect to the whole world. Anyway, that's a lecture for another day. So I'm going to delete this tag because this wasn't part of the lab. That was a freebie. Okay, back to the lab. So we expanded out in the lab our T4 data file. Now, let's do some I/O. In the program, let's go to controller tags. Okay, we'll leave this alone because this is what was in your program tags in RS500, and it's what's in your program tags here. Let's go to controller tags. Okay, let's make some tags that look like SLC500 I/O. We're in edit tags offline, and we type in O for output and 1 for slot 1. And if we want, we can go over here and type in INT, hit enter, and then go back here, and we want to alias it for that tag type right there. And so when we drop down, see, now we have output slot 1 data, bit 0 through 15. So it looks more like I/O. We do the same thing with inputs. Input slot 2, and I keep telling you that you can just type it in. So it comes up automatically in a double integer. Dent, you could just type in INT and be done with it. Doesn't care how the text gets in there as long as it gets in there. You don't have to actually select it. You can type it in if you know exactly what you want. So now this, we want to alias it to that tag. See, now we have false, which we're not going to use. We could use, though. These tags are available to us in data. So you've got input slot 2 data. So we've created some I/O looking tags. So these are variables that we are declaring, but in a SLC500 they would have been pre-declared. Now I/O will always have module defined tags, but they're not pre-declared. You type in, when you add the module to your I/O tree, it puts these tags right here in. So these are pre-declared variables specific to the I/O modules. And in order for the I/O module to function with the controller and communicate with the controller, so to speak, you have to have a data structure in the controller that is a mirror image of what's in the I/O module. Otherwise, the I/O module can't send data to the controller memory unless the data that it's sending fits exactly size and structure of what's in the controller's memory. That's why I/O modules are all pre-declared as far as module defined tags. Now let's do some logic. We've got some We've got some program data files and some controller for I/O. Let's close that and go to our routine. Okay. Now, you could delete this rung if you wanted to, but I'll just leave it in there and create a new one. So to create a new one, I can come up here and click there, and it'll drop one down, or I can drag it down. If I drag it down, see rung memes. These are little things going me, me, me. Like in the movie, what was it, Finding Nemo, the seagulls, as Nemo was swimming by, it was going, mine, mine. I always thought that was funny. That's the only thing I remember the whole movie. So I can put this anywhere I want. I'm going to drop it down below. And I'm going to put in a true if off, like was in the manual. And because this is blue, that means it's already selected. The focus is already on it. It's already selected. All I got to do is type in I2, and it doesn't even have to be capitalized. If I type in I2 and then click here, see, it takes me right to that tag. Drop that down, click data, go to the drop down and pick 0. Okay, now that looks just like a aliased pre-declared module defined tag in the Logix engine. Local, slot 2, input data, bit 0. But now in this case the module does exist. If I go over here, I could delete that module right there, that IQ16F. And that would stay there because the module defined tags, they stay there. These templates stay there. Once you've added the modules, they're exposed for your use. Okay, our rung's not complete. So go back to our rung, and we'll add another true if off, and then we added a timer instruction. Timer counter, TON. And then there it's already selected. We typed in T4. Drop down the list. There's only one tag by that, and then we picked 1. There was a reason that I skipped this one to do this one. It's a programming shortcut, or I should say program creation typing in shortcut. So I'm going to grab that, mouse over, but drag that over to here. And you're going, well, wait, PLC professor. That's a whole data structure, and that's only a bit. Okay. Click on it, or double click on it, then click at the end of it and put in dot, and then we can put in whatever bit we want. DN. So we type in .dn and hit enter. Remember, it doesn't care how the text gets in there as long as the text is correct. Notice what happened when I hit enter. The E's disappeared. That means this is a happy rung. So if that output is off and the timer's not done, then the timer runs. When the timer's done, this goes false, the timer resets. Now we need a little bit more logic, so I just said continue adding and editing the rung to match that below. Make note that I changed some of the memory locations in the finished logic. Okay. This I changed to a 2, but before I do that, I will branch around. I picked this instruction right there. Branch around. Drag it over to here. And I want to add another branch level. And here I want a true if on and an OTE. And here I want a true if on and another TON. Okay, so I'm going to try something I didn't tell you to do in the manual. I'm going to go T4 bracket to bracket. Okay, and that should work. Now notice that I put some presets in there too, so that should be 1000, and this should be 500. Another thing you may have noticed, if I put a tag in here, or if I type something in that's not defined as a tag, these will be question marks down here. They won't be zeros. So now we want T41 timer timing bit here, so we drag down T41, double click, click, dot TT, enter. And then we go over here and we type in 01, and we could just put the rest of the tag, but we'll go find it. So there it is, output 1, data, and we want bit 0. This trueifon is, we'll just drag that down even though it's not the exact same tag. Double click, click, backspace twice, DN. Okay, now I think that matches what's in the manual. Input to 0, T4, oops. Got double click, click, right behind the 1, backspace 2, enter. Okay, so you're just editing text. But the text that you edit, it points to a memory location when it reads the logic. So input slot 2, bit 0, T42, done, not done. Start T41 for 1 second, 1000 milliseconds. While it's timing, turn on this output. When it's done, start this timer for 500 milliseconds, half a second. And when it's done, make the whole rung false and start over again. Okay, save, download, go online in the run mode, and test your logic. So, okay, save, right there. It's saved. Now, I always tell everyone, when you're going to download, go to Communications, Who Active, and pick the actual bad boy that you want, then download. That way you're being deterministic. You're pointing, you look to see where you're going before you go. If you go over here and do it, download from here, if you've only got one controller out there, well, fine, you can't go in the wrong place. But that's not a very realistic scenario for the real world. In the real world, you're most likely going to be in a manufacturing facility, a plant, on a network where there's hundreds of PLCs. And you can only imagine what would happen if you downloaded to the wrong PLC, stopped one cell in a series of cells that is manufacturing something that's worth $1,000 each, and you trash a dozen of them because you downloaded to the wrong processor. I'll tell you what to do if that happens to you. Set your tools down, act like nothing's wrong, walk slowly to the locker room or to your office cubicle, whichever you have. Don't start sweating and showing fear because people wonder what you're up to. Take a few things that you can put in your pocket that are important to you, walk slowly to the door. When you get to the door, run to the parking lot, get in your car, and drive to another state because they're going to burn you at the stake for making a mistake like that. So, if you want to go ahead and download from here, that's your business. I don't know if I've ever downloaded to the wrong processor or not, but I always like to make a little joke out of it, even though it is not funny. Okay, we're downloading. Downloading. This segment is going way longer than what I wanted, but what am I going to do? Bust it up into 2 sections. Now, it turns out that we're almost done here. We're going to test this logic, and then we're going to create another rung that behaves the exact same way, but with a style of programming that you can do in 5000 you can't do in 500. Okay, change to the run mode. Okay, you see the timer's timing, and that's going on and off. It's on for 1 second and off for half a second. So this is a flasher. Now, I'm going to do this other rung online just for grins. When you do stuff online, you're always taking a chance that you're going to have to go offline to fix it. So I'm going to drag down a rung here. See the rung memes? Now I got 3 of them, like 3 little baby birds in a nest. Mama's got a worm. I got the worm here. They're all going, me, me, me. I know that's stupid. Okay. So now we need, and I'll show you a little trick. Okay. And you can only do this when you're online. I can grab this and drag it down here. But it didn't move it. It copied it. But if I was offline, it would move it, which you don't want to do. So I'm going to drag this, bring it down, grab one of these, bring it down. I'm going to do something I've never done before. I'm going to grab this. Well, I don't know what's going to come down with it, though. Nope, don't want that. How about this? Nope. I better stick to what I know here. Do a branch around. Now I can grab this. I'm going to put it right here, though. Not there, right here. See, now I still have my branch around. This one I'm going to grab. Instead of putting it here, which will create another branch, I'm going to put it here, which puts it in the branch. Pretty cool, huh? But be careful when you're doing this. If you move instructions from this other rung, move instructions from the other rung, then that rung's not going to work right. Now, this rung is not correct, but I just want to show you that. So now what I'm going to do is I'm going to take this guy and put it here. I'm going to take this guy and put it here. This guy I'm going to put here. And then I'm going to delete, and I'm going to put a branch around these 2 guys. And I'm going to put in here, in here. There's my rung now. I'll stretch it out here to see if I can. Okay, there we go. That's what I wanted. Now there is still something wrong here. I've got all these instructions pounding on the same tag name, so I'm going to have to come up with a new tag name. So here, and notice that changed to a 1 because this tag already exists. I didn't create a new tag. Now here, I can't use T42 again, so I'm going to use T44. Okay, you see what happened? When I did that, I killed one of those brackets and messed it up. So you got to be careful when you're doing fat finger editing. We'll make this timer 3. This then should be timer 3's timer timing bit. So I'm double clicking and clicking right behind what I want to change, backspace 3, and this of course double click, click, backspace 3, double click, click, backspace 4. One more thing to change, double click, click, backspace 1. Now these are all unique memory locations now. Now when you're online and you make edits, you got I's there. I's mean it's insertable. It's ready to be inserted into the actual running program, the running logic. It's not running right now. And because it's a rung that we didn't really edit, in other words, it was a new rung that we brought things into. So anyway, make a long story short, go to Finalize All Edits, and then say yes. You read that file more than once, you're a sissy. Just joking. You should always read this stuff. Don't tell your boss I said that. Okay, so now these are 2 separate rungs. I mean, they're executing against different logic. So this one we'll take and make this 505 to put it out of sync. See, you can see they're going on and off at different times. And we'll make that some other value. So you can see there's no synchronization now between those two outputs. Now you can't see it, but on my hardware trainer, my lights are flashing. Because remember, these are actual real I/O. We aliased it to the actual I/O tag names. But let's say that we didn't actually have those I/O modules down there. If we didn't, we would go in to their properties, hello properties, and we'd go to connection and we would go inhibit module. If we inhibit the module, we do that because we don't want the controller to think the module's there, but we want the tag data types there. For those of you who are not using real I/O, in other words, if these memory locations right here, this input, that output, this input, and that output right there, if they're not actual I/O modules, but they can still be those tag data types. And all you have, and this would run exactly the same. If I deleted those two I/O modules, those rungs would still be executing exactly the way you see them, because everything is taking place in the controller's RAM, in its memory. The logic is reading tags, executing logic, and writing the tags. It has nothing to do with real inputs or outputs. It just so happens that I have an input and output module connected up to all this. But if those I/O modules were not there, then this light would be flashing right here. I/O OK, it would be flashing, and when you went down here to your I/O configuration, there would be a little yellow triangle next to each one of these, probably one here, one here, and one here, saying we're unhappy. And then if you right click, it would come up and say that it couldn't find the module. It would give you some sort of an error. But if you inhibit the modules, you won't get the green flashing light. It's as if the modules weren't even there, but the tag data types are there for you to have used to create all this. Okay, we're going to leave it at that. This thing's gone way too long. Thank you for your attention, and I'm sorry it took so long. Thank you. Okay, thank you for watching Creating a Slick Looking Database, which is a lab exercise in an introduction to RS5000 using lab projects and examples. This is a standalone lecture in a sense, even though it includes some of the logic and stuff that you did in a lab exercise. You could watch this video all by itself and still treat it as an individual lecture. So thank you very much for watching.